Welcome to this next video for the reverse engineering course of eLearn Security. This video is associated with the chapter 6 of the reverse engineering course. In the previous video, we saw a demonstration of how we can locate the algorithm we are looking for by looking for string references. We also went through some basic code modification in memory, as well in the physical file on disk. And we also had the opportunity to manually calculate the physical offset of a specific byte by knowing its virtual address and, of course, some more characteristics about the section in which it belongs to. Talking about string references, we're going to see that this is not always the best way to use in order to locate the algorithm that we are looking for. And this is because some strings might be encrypted inside the application, which means that a string that we see through an output of the application itself might be encrypted inside the code. So at the moment we are going to search for string references, we might not be able to find it because, as we said, it's encrypted. So in this video we are going to see a demonstration of how we can locate the algorithm we are looking for by retrieving information from the stack of the thread under execution. Talking about stack and threads, keep always in mind that each thread has its own stack. However, this is not going to be a problem in this case, since the user code runs from a single thread. We will start again by running the application and try to observe what happens. So we're going to put again a random code, press on the check button, and we see again that the application says that the code is invalid. So apparently this application looks quite similar to the previous one. However, there are some differences that make this application what it is necessary in order to go through this video and demonstrate why string references might not be the best way and why the stack and the information that keeps might be our best friend in many cases. So let's load again this challenge with Holy Debugger and try to locate that specific string reference. As we can see now, we don't see it among the top, so let's search for it. As you can see, we are not able to find any. Now, another reason for which we wouldn't be able to find a string reference is because that memory address where the string is stored might be accessed indirectly through a register. So let's see if this is the case. What I'm going to do is that I'm going to load the first challenge again to Oli, search for string references, and then here we can see in which address the string is located. So we do following dump immediate constant, and then here we choose text ASCII. So we can see here the string. If we scroll up on the top, we see which is the base address of this section. In this case is 63B and 3 zeros. So the strings are located in the data section. Let's go back and check the data section also in this case. We can see, for example, the title of the challenge window, but we can't find that specific string. So let's search for it again. And again, we can't locate it. So this means that something else is going on and this string is not accessed indirectly. through a register. However, what we do know for sure is that at the moment that this string is displayed in the message box must be decrypted. So let's just run the application, enter a code of our choice again, press on check button, and once the message is displayed, let's pause the execution. So let's go now and explore the contents of the stack. Remember that the stack is a LIFO structure, which means last in, first out. So new information is going to be pushed on the top. So towards the bottom, we have older information, older data that was pushed. So let's start scrolling down and see what we can find. So we can see here that there is a reference to this string. So this string must be located in address 63B320. Indeed. But now you can see that the string is stored as Unicode. So right click, text, Unicode. Let's keep scrolling down. Now we can see both the title of the message box and the message itself. Again. So we know that the message box API was called from this address here. So let's right click and follow in this assembler. In order to be more accurate, what I meant by that is that this is actually the return address after the call to the message box. So from here we can locate the call because we know the return address. So let's scroll up to the beginning of this function, and we're going to set a breakpoint here in order to examine the whole function later. Now what else you can notice is that at this point here you can see that in these two locations these two strings are visible, which means they are decrypted. So if we follow in dump, immediate constant, you can see both of the strings, and before we were not able to do that. So this means that at some point these strings are going to be decrypted. Now at this point, since we know the return address after the call to the message box, which is here, we're going to set a breakpoint directly after. So I'm going to press F9 to resume the execution, and then press OK. So now we stopped immediately after the call to the message box, and here you can still see those two strings decrypted. So let's keep stepping over with F8. You see now that this string is not visible anymore. Let's now again step over this call, which is this call instruction calls the same function. So now we can see the message of the message box, and now we can't. So now we know that this function located at address 42df0 is the one that encrypts the strings. We're going to see this later. So we have the breakpoint here, and we are ready to continue by trying again and see what is going to happen right now. So let's resume again the execution of this process and try again So now we managed to break at the beginning of this function. So let's try to start stepping over the instructions and see if we can find anything interesting. You remember this function? It's the one that encrypted the strings before, and now this is called at the beginning of this function. So let's step over, and we see here a string. Probably this is the correct code. So this function also decrypts the strings. Let's continue. So you see here the two strings. The one is the code we entered, and the other one probably is the correct one. And the call just before the test exex, which is going to cause this jump to be executed when this test exex instruction is performed, and bring the execution here. So probably this is the function, which has also breakpoint, where the checking of the code we enter is done. So let's step over. Again, this function is called. And now you see that we move this address to this address here in the stack. So let's do following dump immediate constant just to see what's there. So you see, now the title of the message box is decrypted. And now it's decrypted also the message of the text. So this function here also decrypts and then re-encrypts the strings for protection. And then the message box is going to be called, which displays that the code is invalid. So let's resume the execution of the application and try this once more. Let's run until we break here. So you can see now on the stack again our code and the correct one. And this function is going to be called, which is going to be to do the comparison, which of course is going to fail. Then this jump is going to be taken, and we arrive here. Now you see that we can still see the real code, which is here. And then this function, which is dedicated to encryption and decryption of the strings, is called. And look at the parameter passed to this function, which is actually the address of the string. So let's see now what is going to happen once this function is called. So we press F8 once to step over, and you see now that this string is encrypted. And now it's going to decrypt these two strings for the message box. It's going to display the message box, and then you see still the strings here, and now it's going to re-encrypt them in order also to protect the strings from static analysis and from easy, let's say, reversing through string references. At this point, what you should do is try and patch the executable in order to make it always accept the code. You can use any type of modification you want in order to achieve that. Remember the three types of patching: techniques that we showed in the previous video. In any case, you saw how it is possible to obtain very important information from the stack during the execution of an application and successfully manage to identify the algorithm that we were looking for. So I hope you had fun again, and see you in the next video.